member hour. I'm Chuck Roth, currently MDC chair in ASABE. And here today, our guest of honor is Dr. Roger Hoy from the University of Nebraska, Lincoln. And most of you know Dr. Hoy, but if not, he's an alumnus, I guess, as it is, of the University of Georgia. In ag engineering, and then followed that was his bachelor's, followed up with MS and PhD from NC State. And then after that, he was with Danaher for 10 years before moving to John Deere, where he was a staff engineer working on tractors for about 7 years. And then in 2006, he saw the light and came back to the academic world, but to Nebraska Lincoln, as was previously discussed, as professor and the head of the Nebraska Tractor Test Lab. And outside of work, Dr. Hoy's been a key ASAB member for quite some time and served in many capacities, most recently serving as a trustee currently. He also cemented that ASAB legacy by becoming a fellow in the organization in 2015. And along the way, he's published about 20 papers, including a distinguished lecture that's part of the ASAB AETC series. So today we're setting this up, and we gave Roger the task of educating us on the history of the Nebraska Tractor Test Lab. But before we begin, a couple of housekeeping items. We'll have Roger give his presentation, and then we'll follow it up with some time for questions, answers, and just general discussion. This is meant to be not just a give and take or back and forth, but also, if there's any discussion among the group, that's okay as well, but please hold that until the end, and just remain muted until that discussion time so that we can not interrupt Dr. Hoy. But if you're like me and you've got questions that you're afraid you're going to forget, do feel free to put them in the chat window, and then I can bring them up, or Roger can read them at that time, and we'll work our way through those. So any questions before we begin? All right, if not, Dr. Hoy, the floor is yours.
Okay, thank you. Let's see if I can do this right. So hopefully everybody's looking at a slide that says the history of the Nebraska Tractor Test Lab at the top. So I'm just going to spend a little time today just talking about how we came to be and what we do. For those of you that might have heard the distinguished lecture presentation at AETC in 2020, I'll forewarn everybody I have stolen shamelessly from that presentation, but we'll see how it goes. If I can make my mouse work. Okay, so before the Tractor Test Lab, just going back to the history of these things, we had steam tractors that actually appeared shortly after the American Civil War. But it really wasn't until right around the 20th century that a tractor, as we might recognize them, that was powered by an internal combustion engine, was created. So in the early days of our profession, there was a lot of interest about these new machines and what they could do. So one of the first attempts by the forerunners of agricultural engineering was to conduct some plowing contests. And these were actually held up in Winnipeg, Canada. The first one was in 1908, and then the last one I think was held in 1913, primarily due to World War I, which Canada got involved with in 1914. Of course, the United States didn't participate in it until 1917. So one of the people that helped put this together was a former ASAB president from the early days named Leon Wilson Chase. He was actually a UNL graduate from 1904, and he was actually the first head of the University of Nebraska's agricultural engineering department. But he served as a judge of the event in 1908, and he directed the entire affair in 1913. So Chase perceived there was still quite a lot of value in conducting these contests after they were abandoned in Canada. So he moved them to Fremont. I think it's lost to history a little bit about exactly what years that occurred, but we do know that in 1917, Chase tested 1990 tractors there. And what this event did for the Nebraska Tractor Test Lab was it developed some of the early equipment and some of the techniques for early tractor testing. So this tractor that's shown here is a 1916 Model B Ford. And this wasn't a Henry Ford tractor, it was a Minneapolis Ford. So my predecessor created this slide originally, Leonard Bashford. It was named because the Ford belonged to the company, not because the company belonged to a Ford. This particular tractor was bought by a Polk County, Nebraska farmer named Wilmot Crozier. And he found out it didn't work, it broke down, he couldn't get service and parts, no dealer. He convinced the company to exchange his 1916 model for a 1917 model, which was supposed to be new and improved, but he found it was just it was just a year late, newer tractor built the same way as the 1916. So he was persistent and he bought a Little Bull. And this particular tractor was like a flash in the pan. It was the highest selling tractor for like 1915 and then faded quickly. But some of the advertising on the Little Bull was typical of the time. Does the work of 5 good horses and sells for the price of 2 poor ones. Is light and can travel anywhere, which he found to be a complete fabrication. But the real competitor for a tractor in the early days really wasn't another tractor, it was the horse. So, these things were sold as they would last forever, they didn't die, they didn't get health problems, you didn't have to feed them over the winter when you weren't using them, and so on. That was the selling points. So the fourth tractor that Crozier ended up with was a Rumbly Oil Pull, which didn't give him any trouble at all. This particular tractor, I think, was the first internally lubricated machine. And so there's a picture here of one actually harvesting wheat. It's a period photo. So Crozier got asked the question, if one manufacturer could build a dependable tractor, why can't all tractors be dependable? He was elected by his friends to the Nebraska legislature from Polk County. And at that time, Nebraska was a unicameral, not its current bicameral. But he teamed up with State Senator Charles Warner, and they wrote a tractor test bill, which passed the legislature in 1919. Only one dissenting vote. That's pretty good even for Nebraska these days. Now, Dr. Chase was serving in the Army. He was a colonel working for the Army in Washington, D.C., but he provided a lot of the technical information required and helped with the requirements of the law. And one of the things that Dr. Chase got written in was that the University of Nebraska's Agricultural Engineering Department was responsible for testing advertised claims. And you had to have a parts warehouse in Nebraska and a repair facility in Nebraska. And if your tractor actually performed as advertised, you did all these other things, you could get a permit at the time from the State Railway Commission that allowed you to sell that model of tractor in Nebraska. And then lastly, the law created a board of engineers to develop testing procedures and review test results. So we still have that today. The law states the tractor test board of engineers will be 3 engineers under the control of the university who oversee all testing. So this was the first tractor test lab. It's about shown here in the 1920s. It was put up in 1919 as a temporary structure. They tried very hard to get a tractor test in 1919, but it was late in the year and the weather went bad. It actually served as the tractor test lab until 1981, and it is still existent today, housing the Lester F. Larson Tractor Test and Power Museum. And we had several administrators at campus that really wanted the building torn down and replaced with a parking deck. But Dr. Bill Splinter, who was the chairman of the agricultural engineering department at the time, was opposed to that. So one of the things he helped do was arrange for ASABE to designate it a historic landmark in 1980, which protected the building. So I've always been interested in kind of who was in charge of this place. And the first guy was a fellow that was recruited by Dr. Chase named Quadshed. And he was not real passionate about tractor testing, but he was convinced to come in and help organize the lab to get going and to start it off. So he was actually here for the first half of 1920 and tested 44 tractors during his time. When he left halfway through the year, he was replaced with an engineer named Fred Novak, who completed 1921. And then we moved on to Elmer E. Brackett, who was the director or the engineer in charge at the lab through 1925 when he became the department head. He was followed by what was supposed to be the first permanent director that would be long serving, a guy named Lou Wallace. However, tractor testing was conducted at all hours in those days, and meals were taken strangely and infrequently. And Wallace developed a stomach ulcer that he went in for an operation for at the end of the fall season of 29 and died on the operating table of it. So these two guys, Shed and Brackett, were both ASAB fellows, and I think Brackett was probably a president back in his time, somewhere too, of the society. Just another little interesting tidbit on Brackett. If any of you on the phone remember that show that starts about Greg Boynt in the 70s called Black Sheep Squadron or Baba Black Sheep or something, the real life Colonel Lard in that show was actually Brackett's son. Not quite the way the show portrayed him. So what did we test in the early days? We looked at drawbar power. All of these tractors had flat belt drives, so we looked at belt horsepower, and we looked at fuel consumption right from the beginning. So the drawbar power and fuel consumption tests are still conducted today. And I guess the second footnote to this is we've always been kind of a low budget operation. So we've used ag engineering students heavily to do much of the work here at the Tractor Test Lab. And even today, it's a great deal. They work for $9 an hour and no benefits. So gives them an educational opportunity, and we get some useful work out of it as well. So test number one was the John Deere Waterloo Boy Model N. And John Deere had bought the Waterloo Boy gas engine traction company, I think, in 1917. And they had not yet developed a new tractor. So they were still selling this under the Waterloo Boy name, but it was owned by Deere at the time. It produced 25 belt horsepower and 15 drawbar horsepower. It's kind of strange. This was 1919. We have lawnmowers today that put out more power than that. But it officially passed on April 19th, 1920. So that's what we generally consider our initial starting date for the lab, is April 19th, 1920. And you have to ask the question, if Crozier had bought one of these back in 1916, would the Tractor Test Lab exist today? And the answer is possibly not, because at the time Nebraska passed its tractor testing law, both North Dakota and Missouri were considering similar legislation. But when Nebraska acted first, they dropped their efforts, I think rightly assuming that most all tractors would be tested in Nebraska, and it wasn't necessary for each state to go through the same thing. So some of the early test measurement systems, we have an early load cylinder here that's really a hydraulic cylinder that's mounted right between the tractor on test and the drawbar test car. So you could measure the hydraulic pressure that developed in this cylinder, and of course, if you knew the area of the cylinder, you could calculate the force being applied. You could see an early fifth wheel rolling along here that's counting true distance traveled and true travel speed. And of course, if we multiply travel speed by drawbar force, we get drawbar power. And this was another incantation here, kind of a more permanent test car. There's an oil pump unit attached to the back, and this large tractor here is just a load unit. This oil pump unit was used oftentimes just with this car, and essentially it just pumped, had a ground-driven hydraulic pump geared the right way to pump oil through a restrictor to create load, and then the measurement and maybe some of the modulating was done right out of the test car. And of course, this track is the tractor being tested. And supposedly this unit actually had a DC dynamometer in it that was driven by the rear wheels here of this unit. And so here's another view of just the oil pump unit that's a little better, attached to that same test car we looked at a minute ago with tractor under test out here on the right. This would have probably been taken sometime in the mid to late 1930s. So an early belt power test. All of our records say we did all of our belt testing inside the lab, but we do have this period photo of the tractor under test connected to a Prony brake dynamometer. And so there's basically this big band clamp here that you would apply to one axle of this that's attached to on a shaft to the other pulley that's connected to the tractor, and that would apply the load, essentially just make a lot of heat. 1930, when Wallace died, they reached out to a gentleman named Dalton Zinc. And Zinc had a really famous career. He was an instructor here at the University of Nebraska prior to 1930. And one of his students was Lester Larson. And Larson remarked that when, Zinc was always a very approachable, easy to find instructor, but when he got stuck with the tractor test lab, he became hard to get hold of. But he served as the engineer in charge from 1930 to 1941. He's also an ASABE fellow. After leaving Nebraska at the beginning of World War II, he went on to a very long and distinguished career, first with Firestone Tire for a few years, and then he did his best work, I think, with John Deere. He was one of the very early pioneers and proponents of drops-on tractors during his time at Deere. And so we upgraded the dynamometer a little bit from the Prony brake. What you got here is a 120 horsepower Sprague DC dynamometer. So essentially, this is really just a big electric generator. And the electric current that's produced was dissipated through these resistor banks. And so this is Dalton Zinc again, and he's basically adjusting a switch that controls how many of these banks are engaged at the time. Back before load cells, we would have a scale attached to the arm of the dynamometer that you'd have to go on here and balance to find the force that it took to keep the case from rotating. And then, if you multiply that force by the distance to the center of the shaft, which I think was about 24 inches, you would get torque being produced. So kind of the other side of the wall from the dyno is where we'd anchor a tractor down. So there was some eye hooks in the floor that you could tie a chain off to and put a little tension on the tractor to get appropriate belt tension. If anybody visits the Larson Tractor Museum, you can still see these tie-down points in the floor, usually marked with yellow so nobody trips into them. One of Zinc's other big accomplishments was an upgrade of the test car. And so this is known as the Adams test car. It was built by one of the engineers that worked here named Charlie Adams. Charlie went on to a very long and distinguished career with Oliver and actually constructed their drawbar test car too after he left UNL. You see the hydraulic load cylinder here. I think this was the 10-inch variety diameter, and the chain going to the tractor under test. And then there's another load unit on the back. You know, this car itself was good for about 4,000 pounds of pull, so anything larger required load units. It's kind of what the inside looked like at some point in its history. You've got a large pressure gauge here that's measuring the pressure in the hydraulic cylinder. This was not in 1938 when it came out. This was later on. We actually have a strip chart recorder here that's plotting distance traveled versus drawbar pull. And you have various counters for engine RPMs and wheel counters and so on here. And so this is what it might have looked at. It's like sometime prior to 1956 or so. I'm sorry, 1960 or so. Actually, pre-56. Tractor under test is this crawler. Then the load car. Then the rest of this are just load units that are applying enough force to actually give that tractor under test enough load to test. And we didn't have nice Coriolis flow meters for fuel back in those days, so a big part of the operation is weighing the fuel. So sitting on the scale here is a day use tank for the tractor under test. So you would measure this precisely at the beginning of a run. You would install it on the load car to pump to the tractor. And then when you got done with that particular part of the test, you would come back and re-weigh it so you would calculate the fuel expended for doing a particular operation. So there was a lot of going back and forth on weighing the fuel. In the 1930s, fuel type was a huge issue too. This was just one graph that was produced by the Tractor Test Lab as part of an extension publication where they track different types of fuel by year. So, you know, in the early days, it was kerosene and gasoline. Then there was a tractor distillate fuel that started creeping in the 1920s, 26 or so. And then we see diesel starting to become more prevalent starting, I guess, about 1932. And of course, today it's nothing but diesel. We haven't tested anything but a diesel tractor officially since 1978. Another interesting thing happened in the 1930s was these steel tires with lugs, or steel wheels with lugs, were supplanted with pneumatic tires. And I found it interesting, just reviewing some of the old history, that some of the early studies on pneumatic tires were conducted right here at the Tractor Test Lab. And Lloyd Hurlbut, who went on to become the department head at the University of Nebraska's Ag Engineering Department after World War II, and an ASABE president and fellow. As a graduate student in the early 1930s, worked with Chauncey Smith, who has been around tractor testing from the time it began until he retired in the 50s, to conduct steel versus pneumatic tire testing. But we didn't actually see it factory installed until 1934, and that was on an Alice Chalmers WC. In 1937 was the last tractor tested using steel wheels, which was John Deere G. And this is not totally fair to Deere, because in the period 34 to 37, it was common for manufacturers to send out both pneumatic tires and steel wheels. But after 1937, steel wheels were completely abandoned just in a 3-year period for pneumatic tractor tires. So Zinc served as the chief engineer until through the end of 1941. And with the U.S. entering World War II at the end of 1941, production really changed from agricultural tractors and other commodities into producing war material. So the lab actually was shut down during World War II, and Lester Larson got it running again at the end of World War II. He is also an ASAB fellow. He's the longest serving director of the place for a 30-year period and about 800 tested tractors. Just some interesting stuff. The lightest tractor we ever tested was this Choremaster, 1 belt horsepower and 0.7 drawbar horsepower. It was a walk behind, so the operator's actually riding on the front of the load car. This is always interesting to me. After World War II, there was, hundreds of thousands of Jeeps floating around and a nice business for making Jeeps. So Jeep decided they would modify their Jeep a little bit and call it a tractor. So they put a power takeoff on it, an optional 3-point hitch. My grandpa bought one of those after World War II. He always considered it as the stupidest thing he ever bought for farming. But Dodge got into the act as well, and they started putting a power takeoff on their pickup. So it became a tractor, and we tested it. 1956, last time we did Steeltrack earth moving equipment. So this is still the heaviest tractor we've ever tested at 66,025 pounds, although we did have a 4-wheel drive get close to this number in recent years at 66,000 pounds even. It's also the most drawbar pull by a Steeltrack crawler, and since we don't do Steeltrack crawlers anymore, that record's going to stand for a while. And also in 1956, we went away from the clay cinder dirt track to a concrete track. The Board of Regents budgeted $25,000 for the effort and actually came in at $30,000 to create it. But this is soon after it was built, and you can actually see units out here on the test track. And you also see a prevailing dirt track that existed around this track. So here's that nice little temporary building from 1919, and the current tractor test lab, of course, hasn't been built yet. For those of you interested, this is Chase Hall, which is where agricultural engineering was taught, still is taught. And then that little car from 1938 was modified extensively over the years. This is about a 2001 or 2 era picture. So about 1960, it was just too small to be useful, so it was mounted on an Oliver chassis. This is actually the 3rd Oliver, and that got its capability up to about 10,000 pounds on its own. I still see the big load cylinder there for testing the tractor. This is some variety of 9610 or something like that from Deere, and you can see the yoke of another load unit that's attached to the back of it here. And getting out of this is Brett Sampson. Brett retired in 2017. He's still around. He has been involved in more tractor tests than anybody else in the history of the tractor test lab, over 1,000. So we've always been guided a little bit by the farming community, and some of our sessions with farmers were revealing that these tractors were pretty loud and they'd like to know how loud they were. So we instituted a sound test in 1970, and this is some of the original equipment that was used for that. So the manufacturers were not at all enthusiastic when we said we were going to start checking sound. And the first sound test was performed in April of 71. 97 decibels at the operator ear was the measurement. And so sometimes when we do something like this, it turns into a good thing, because You know, the tractor lab was really established, and the tractor law was really established to get all the fly-by-night manufacturers out of the business back in the late 19 teens and early 1920s. But a funny thing happened. We started publishing performance numbers, and everybody's marketing department started competing on it, which they still do today. So when we started publishing sound numbers, marketing department saw those numbers and saw competitor numbers, and they started to become design criteria to be quieter than the other guy. And you know, today, if we get in a cab equipped tractor, and we've got 8Rs in the lab right now, you know, noise at the operating station might be 67, 68 decibels. I don't think we could claim full credit for reducing the noise of tractors, but I do think maybe implementing the sound test was a catalyst that maybe caused it to happen 10 or 15 years earlier than it otherwise might have. So kind of the test car interior in the 70s, we've got the strip chart recorder, there's an engine tach up here, drive wheel counters, engine RPM, the pressure gauges, and so on. It was always kind of fun to run this thing. At least in later days, we put a kid in there with an old laptop with Excel on it. And 2 or 3 other people would make various measurements along the way. And the guy with the computer was responsible for getting it all written down onto each line properly. So Lester Larson retired in '76, and Lou Leviticus came on board, and he was here for about 20 years. Tested about 600 or so tractors, or 500 and something tractors during his tenure. So when we had this concrete test track built in 1956, so when we got something big in, we didn't have enough width for it, so we would go out to the Lincoln Airport, and we would rent space out on one of their unused ramps and set up a tractor testing course. So here's one of those. That's actually a big bud in 1981 with a bunch of load units behind it, and we kind of used traffic cones to lay out a test course there. But you know, it was a nice, pretty level section of concrete that we could use. 78 was an IH 284, last gas tractor tested. Everything since then's been diesel. 1980, we got a new tractor testing facility. So it's a modern, well, for 1980, a modern looking building. I guess it's getting old now. It's about 40 years old. That's kind of looking at it from up on the test track, sort of taking a shot to the northeast corner, or looking northeast to the southwest corner of the building. The entire building is not tractor test lab. Probably from about this awning to the west is all tractor lab. The rest of this is instructional space and research space for the rest of the biological systems engineering department. 1984, we added a hitch lift test. So this is just an example of one of these. You know, I said we were sort of a low budget operation. So what we've done is we've borrowed about an 18-ton forklift mast on this hydraulic cylinder, and we can exert a hydraulic load against the hitch. So we're pulling against this load cylinder. Actually mounted on the hitch is a completely balanced implement. So this particular test, we're not looking at the force at the hitch balls. We're looking at the force that can apply 24 inches behind the hitch balls, which is a typical, at least at one time, center of gravity location for many implements. So this is the current dynamometer that's in use. I put a 2021 date in it because it was a 700 horsepower dry gap dyno that got fried right at the end of last year. So we decided with tractor power increasing, it would be a good opportunity to upgrade it to a wet gap. So we now have to go up to 1200 horsepower. I don't see need of that just yet, but I do feel we're going to go over 700 in the next 5 years. So we're prepared for it now. By 1988, implement-driven hydraulics had become pretty common, so we introduced a hydraulic flow test. So this is essentially what sort of pressure can the tractor develop and what sort of flow rate can it create at various pressures. And of course, with hydraulic power, if you multiply flow rate times pressure, you get to actual power measurements. So we published the maximum hydraulic power. So when Lou retired, my predecessor, Leonard Bashford, took over running the lab. And I think with him, we changed the title from chief engineer to director at that point. Leonard was always an unreconstructed agricultural engineer, so he referred to himself as an endangered species. But he was around until 2006, and he was involved in several upgrades to the lab. So we did a case stagger quad track in 2016. That was the highest drawbar power we ever achieved at almost 562 horsepower. Heaviest rubber track tire at 60,320 pounds. Let's see, highest PTO power ever we've seen was on a Cant Challenger MT875C at about 586 horsepower at maximum power. And I believe this is still correct that the most fuel efficient tractor we've tested was the John Deere 8400 at about 20.9 horsepower hours per gallon. And that was 17. So people ask, how do we pay for it, the operation here? And the Tractor Test Lab has always been a self-supporting entity. So essentially, we pay for ourselves by charging for a fee for each tractor we test. So back in 1920, we didn't charge, and the university quickly realized that that was going to be a problem. So they went back to the legislature and got them to change the law to allow us to charge reasonable fees. 1921, a fee of $250 per model was established. That's ratcheted up a little bit over the years. I'd say current day, it's a little bit varied based on how much time is spent on tests, but typically about $23,000 for a tractor over 100 horsepower that we do drawbar testing on, and typically about $11,000 per model for a smaller tractor. And I still say it's a great deal. I mean, back in 1921, $250 was a lot higher percentage of the cost of the tractor than $23,000 for an over 100 horsepower tractor is today. So the law has changed a bit over the years. So 1919 we started, 20 we had the change I just mentioned. Back in 1920, there was no real differentiation between agricultural tractors and construction equipment. So by 1956, those market segments had kind of developed differently, and it was recognized that the real purpose of the tractor law was to protect users of agricultural tractors. So a more modern definition of an agricultural tractor was created that eliminated construction, and also some of the budding water guard products that were starting to appear. 1967, the Railway Commission ceased to exist, and the Nebraska Department of Agriculture became the enforcement agency for the tractor law. Big change happened in 1986. We joined the Organization for Economic Cooperation and Development, tractor test codes and schemes. So that really allowed the NTTL to participate worldwide. So for manufacturers, it's a good change. You know, if you design and build a tractor here in the United States, you bring it to the Tractor Test Lab. But if you're doing it in some other country that has an OECD station like France or Germany or Italy or India or wherever, you can have your tractor tested locally, and we will accept the test results for our purposes here in Nebraska. Let's see, 1989, we, not through law, but through the Nebraska Tractor Test Board of Engineers, removed the requirement for drawbar testing under 100 horsepower, as it was deemed tractors of that size and smaller just weren't used in drawbar applications significantly. And then the most recent change was in 2012, where we actually made testing under 100 horsepower optional. So there's a stick and carrot to that. If you're selling to professional farmers you want to continue to test because the tax exemption for farmers is removed on non-tested tractors. So the idea was if you're selling to just homeowners or utility type things that aren't agriculture, you need that test. But there's an incentive if you are selling to farmers to continue to test those smaller tractors. And I'm going to just sort of stop here today on this slide. That's kind of our biggest load cylinder that we ever used, and that's our yardstick. And we have measured everyone with the same yardstick. We actually switched to load cells a couple of years ago, but this is too good of a picture not to have today. So I guess, Chuck, at that point, I'll stop and we can take some questions or have some discussion or whatever anybody'd like to do.
Yeah, well, first off, I'd say thank you, Roger, for your time. Really appreciate it. I would
Probably
open it
talk
up.
longer than I was supposed to, right?
Oh, well, that's okay. That's okay. I would open it up to any questions from the group. I don't see any in the chat window, but yeah, I'll let you guys go ahead and ask. I know I've got a couple, but I'll let somebody else start out, and or if there is no one, I'll ask mine.
Chuck, I see Mark has one in the chat.
Oh, yeah, go ahead. So yeah, Mark Diltz is asking, how many tractors would it have taken to get the Ever Given out of the Suez Canal?
I have no idea, but it seems like I saw a Deere 4-track hooked up to that ship, and it looked really, really puny. So, you know, our largest tractors are maybe somewhere around 600 horsepower these days. And, you know, those ships like that one are, you know, I don't know, hundreds of thousands of horsepower coming out of their engines. So it might take more than one.
Fair enough. Based on your slides there, maybe one could have argued that we should have used a quad track instead, as they seem to weigh more and maybe have more drawbar power. I dig it myself, I guess. Any other questions from anybody else?
Yeah, this is Sonia.
Yeah.
I have a question.
Go ahead.
Can you hear me?
Yes.
Yeah.
Okay. What testing typically do the manufacturers do before they send a model to the tractor lab?
Well, some of them do nothing, and that usually doesn't work out too well. You know, the ones that have been doing it a while have learned how to almost duplicate the test we do here back at home first. So, I mean, there's some obvious things you want to do. You don't want to come with brand new tires because they don't pull as well as ones that are worn just a little bit. You don't want to come with a 0-hour tractor because there's wear in that happens in the transmission and the engine. So when you break them in for 80 or 100 or so hours first, you usually get better results. You know, for a new company coming, there's usually learning experiences on both sides, and about the, you know, second or third or fourth time they come back is always a lot smoother than the first time. We're happy to share with anybody what we know about how to be successful. It's just some don't always ask the questions of us.
The Minnesota section had a presentation by a member of ASABE who's works for AGCO in their testing group, and it was extremely interesting to hear some of the things they were, and saw the pictures of the area that they were using for testing.
Yeah, you
Thank
know,
you.
so that's an interesting comparison because AGCO kind of moved their Challenger line up to Jackson, Minnesota. I don't remember when exactly, early 2000s, and they had some growing pains to go through. You know, a lot of the former people that had designed and tested those things didn't want to move out of the Peoria area, so they went back to work at Caterpillar, and they're actually very competent at it now, but that was not the case soon after they made that move.
Chuck, may I ask a question, Roger?
Sure.
Roger, seeing the belt on the tractor, and certainly the earliest tractors still had a lot of belt efficiency and belt usage. Is there records or any indication whether the stationary, the hit or miss engines were ever tested?
I'm sure that somebody tried to test them, but they would not have been part of an official tractor test. Because those are what Darren's talking about was essentially just an engine with a belt drive mounted on it. It was a power unit that could run a threshing mill or power an irrigation pump or whatever. And it's kind of a predecessor of the tractor. You know, they built these engines. Then they put them on dollies with a handle you could drag them around, and then the tractor was kind of the next step. Let's power the drive wheels down. But that, you know, the introduction of those would have predated official tractor testing.
Looks like Mary Lee has a question.
Thanks, Bobby.
I have one following you.
Yep. Yeah, Roger, thank you. That was really interesting. In the slide about the cost for a test, it said that there could be some variation related to the time that testing takes. So how much time does testing take?
Well, the formula we use gives you the same price for up to 20 hours of testing. So if a manufacturer comes that's prepared, where we don't have to redo a lot of stuff, you can get out for 20 hours. Now, you know, if they want to add some optional testing on, like sometimes we do ballast, all of our drawbar testing has to be done unballasted. But oftentimes the manufacturer will also want to ballast the tractor, and you know that might add 5 or 6 hours to the test time, and they might go over a little bit. But it's at that point, it's a ratio that's based on the number of hours in excess of 20 to the PTO power or estimated PTO power of the tractor. So the more powerful tractors, you get a little bigger charge. The lower power tractors, if you go over 20.
Great, thanks. Interesting.
Roger, I saw,
Bobby?
yeah, I have actually got a couple, but the one I was really interested in was the electric tractor. I noticed you had some quotes in one of the advertising for one of the electric tractors, but they're all under 100 horsepower. Is there any intentions of testing those?
Well, I was going to save this in case anybody asks me to come back again, but we played with a couple of electric tractors about 3 years ago from a company called Steeltrack out in California. And one of them looked like about a 1960s or 70s era Ford of maybe 45 or 50 horsepower. And the other was really modeled after kind of that 1930s Alice Chalmers G, I think it was. It sort of looked more like a go-kart than a tractor. And so on that latter one especially, there was a battery pack permanently mounted under the seat. And you had 3 implement locations behind, in front, and underneath, and you could put a battery pack at any one of those locations. And what they were really, I think, going after were the orchard and vineyard markets of California. So we couldn't do any drawbar work. It wouldn't move our load car, not big enough. But we did do PTO testing, and we did some lift testing on them. And I have to admit, I kind of went from being a real skeptic when they first showed up to actually believing that, okay, something's going on here. You know, that might be more in the 1920s era of our traditional tractor technology, but it's going to grow. You know, I think clearly power density of batteries is inadequate today for wide scale use in row crop and so on. But, you know, it's certainly foreseeable that that's areas where we're going to see improvement over the next, I don't know, generation or half a century or whatnot. You know, so we've had a lot of talks about that. OECD is talking about it. You know, we're sort of acknowledging that we probably need to do some sort of test of recharging ability, like time it takes or something like that. But as far as anybody presenting one yet for official tests, that's not occurred.
Thanks. Very good. I see Mark has a question and I'll come back.
Hey, Roger, great presentation. Thank you. I sit on the ISO committee for some of the combine performance testing. And one of the conversations that we've had is a lot of the combine performance standards are written very much from a mechanical standpoint of time to do this or load or power to do X. I guess my question for tractor testing to this point, they've always been for pulling, for applying power, but as you kind of hinted out with electronics, things may be different. Is there any strategy or thought to testing, quote, the intelligence of the tractor as it becomes maybe a machine both for brains and brawn?
Well, yes, there is. There's active working groups going on autonomous tractors right now, decision-making, object detection, so on and so forth. I think from the Nebraska Tractor Test Lab, our philosophy has always been to try to test things that farmers would like to know, or at least things that affect the productivity of farmers. And how you do that with smarts and even electrics right now is not absolutely totally clear. But I think that's the underlying philosophy we're going to go at as we start to figure out how to evaluate and provide useful information about these newer technologies. Is, we're going to try to do it from what's in the best interest of the end user, the farmer.
Thank you.
Roger, and a great talk. I've enjoyed that. I saw one name in your presentation that I didn't associate with that particular test car, and that was Frank Zaz's name. What was his association with that test car?
Frank Zaz and John Carlisle did all of the welding, and Zaz still complains about this to this day, to take it from its own four wheels and put it on the first Oliver chassis. And for those of you who know Frank, he is another very distinguished University of Nebraska alumnus. He might still be here, except the department head at the time told him he had to start teaching classes, and he didn't want to do that. So he went and had a very long and storied career at John Deere. And he's quite a character if you had the opportunity to meet him someday.
Loved working with that guy.
He's got some macular degeneration issues today, but his mind is just as sharp as a tack. I still talk to him a couple times a year. Usually when he tells me I've screwed something up. We argue about that too at times.
Roger, I was curious, what constituted a pass on the original test? I think you said the first test was a pass. What was it? What did that mean?
Well, it meant that the power that was actually observed during testing equaled or exceeded that which the manufacturer was advertising. So you're going to stick me here. I don't remember exactly what Deere advertised for drawbar and belt horsepower on that Waterloo Boy Model N, but whatever the numbers were less than or equal to what was actually achieved during test.
Seemed like there was a time period that the manufacturers didn't put any kind of claims on it until after the tractor test was completed, and then they put it in their advertising literature.
Well, Deere, as a case in point, is famous for that. We generally require them to make at least a PTO power claim or an engine power claim, but when you read about the new series, like go look up an 8R310 today, and you're going to see a lot of blanks. It says waiting for Nebraska tractor test results, and when they become public, they'll go just put those in the advertising. But we still require them to make at least one major power claim as part of the application process. You got to have a little skin in the game, right?
So that's a good question that was also on my list, or that relates to it. How long after tractors are being produced and are for sale in Nebraska do they need to be tested?
Well, we have an arrangement that allows a manufacturer to gain a temporary permit that allows them to sell the tractor before testing. And most companies avail themselves of that because they don't generally want to put their advertising out before the product's available for sale. So we typically, as part of getting a temporary permit, if they're coming to Nebraska, they have to pay us a deposit for a test fee of about $7,000 that's credited back to them against the actual cost of testing. And they have to send in whatever they have for advertising, and that'll let them apply for a temporary sales permit. And then we generally set the expiration on that permit to be about 6 months after the planned test date. So the theory there is we can not only test the tractor, we can get the report written and approved and the permit applied for as part of that testing process. And so I mentioned a minute ago about advertised claims. Different manufacturers claim different things. We have to have at least one major power claim, but if you claim nothing else, you're not in jeopardy. But if you make a sound claim, like how loud the tractor is, or maybe you make claims on observable torque rise or power bulge, we will comment in our reports about any of those claims that are not made. Hydraulic performance and hitch performance are two where people, the hydraulic claim, the most common mistake that gets made is somebody publishes the hydraulic pump performance, neglecting the fact that there's valves and lines and couplers and everything else before we can actually measure the power. So you are never going to achieve your hydraulic pump performance on test, but that still is a common mistake that's made. The marketing people blame it on the engineers, of course, and the engineers blame it on marketing. You guys in the industry know how that thing works.
Chuck, I just have to throw in one last thing. Y'all were talking about what is a Hokie, but even worse, what is a Husker, Herbie Husker? So,
He's a
I had to
corn
get
husker.
some.
We still have corn husking contest here.
I just had to throw out that. So
That's good. That's good. All right. Well, we've reached kind of the end of the scheduled time here. So out of respect for everybody's time, we'll kind of cut it off. I'm sure Dr. Hoy would entertain any other questions via email, phone call, however you can get a hold of him. And maybe as the director of the test lab, he's a little bit more difficult to get a hold of than some others. But anyway, yeah, I'm sure he would appreciate that if anybody has any questions. We will be sending out a kind of just a follow-up survey, short survey after this sometime in the next few days, hopefully. And so look for that. Otherwise, really appreciate everybody's time today. And we'll probably have, I think we've got a few more of these on the schedule. I think the next one is in a few weeks. And we'll definitely make sure that everybody here that's on today is aware of that one, and look forward to seeing you there, and pull along some friends if you'd like. So thanks everybody, and hope everybody's day is going well and everybody's staying safe.
Thank you all for letting me do this today.
Thanks for hosting it, Chuck.
Roger.
Yeah, thanks, Roger. Thanks, Chuck.
Thanks, Roger.
Thank you.